Welcome to my class, Force Part 3. Already in our previous class, in our previous lecture, we studied different types of contact forces. Okay, in this class, we will study what is a balanced force and what is a unbalanced force. Next, what is net force and how to draw the free body diagrams in different situations. Are you clear about that, children? So, let us watch my class and enjoy the class. You observe this animation. On the ball, two equal forces, that is 5 newtons and 5 newtons, are acting on either side of the ball. So what happened to the ball? There is a change in the shape of the ball. Here you observe this one. These two balls are applying 20 newtons, 20 newtons. Here is applying 20 newtons. This ball is also applying 20 newtons on this box. Okay, do you find any motion in the box? The box is not moving. So these two forces are said to be what we call them balanced forces. What are balanced forces? Equal and opposite forces. Forces on either side of the body are said to be the balanced forces. Then what do the balanced force do? Sometimes the balanced forces can change the shape of the body. Here in the case of ball, you observe this one. The shape of the ball changed. You compare here. Okay, here the ball is bulged. Here, see this one. There is a change in the shape of the body because of the balanced force. So we can say that a balanced force can change the shape of the body. What is a balanced force? Equal and opposite forces on either side of the object or the body is known as what we call it balanced force. Here there is no motion in the box because of the balanced forces only. What are unbalanced forces? Before that, you observe this animation. This man is applying 100 newtons force on the box. This man is applying 80 newtons in the opposite direction. So the box moved along the direction of 100 newtons because here 100 newtons is larger when compared with 80 newtons. See, here this man is applying 100 newtons force on the box. So the box is moving along this direction. So these forces are known as what we call them unbalanced forces. So what do the unbalanced forces can do? Unbalanced forces can set a body into motion. So for the motion, what do you need? You need the unbalanced forces. Are you clear about that one? Okay, so unbalanced forces always set a body in motion. Children, you observe this animation. On the box, F1 and F2 are the two forces that are acting along this direction, whereas the F3 is acting in the opposite direction. So there are multiple forces are acting on the body. Now here also you observe this carefully. In our childhood we played this game. What we call this game? Tug of war. Two teams are pulling the rope on either side. Can you guess who is the winner? Generally, the team which applies larger force is the winning team. Are you clear about that one? So let us come to the concept of net force. Are you clear? When multiple forces are acting on an object or a body, how to know the net force? Then what is a net force? Let us discuss the concept of net force in detail. Are you clear? Do you understand the animation here? Okay, multiple forces are acting. F1 and F2 are the two forces acting in this direction, whereas F3 is acting in the opposite direction. So multiple forces are acting on the same body in opposite direction. So the net force is nothing but the vector sum of all the forces that act upon an object. So the net force is the vector sum of all the forces that act upon an object. In the case of balanced forces, the net force is zero. Because of the net force is zero, there is no motion. There is no motion in the case of the balanced forces. So for the movement of the body, for the motion of the body, we need unbalanced forces. What we need? We need unbalanced forces. In the case of unbalanced forces, the net force is not equal to zero. Okay, so how to calculate the net force? The forces that are acting along the same direction are added. Okay, the forces that are acted along the same direction. See this one, F1 and F2 are acting along the same direction, in the same direction. So you have to sum up these two forces. Whereas F3 is acting in the opposite direction. So the forces that are acting in the opposite direction are subtracted. So the forces that are acting along the same direction are added, and the forces that are acted in opposite direction are subtracted. Are you clear? This is the concept of net force. Let us discuss the concept of free body diagram. When multiple forces are acting on an object, how to draw the free body diagram? First of all, let us know what is free body diagram. A diagram which is used to show the relative magnitude and direction of all forces acting upon a body or upon an object is nothing but free body diagram. So diagrams used to show the relative magnitude and direction of all forces acting upon an object in a given situation. In a given situation is known as what we call it free body diagram. So let us learn how to draw the free body diagram of a car. See this one. Let us take a car which is in motion. I have taken a car which is in motion. So the force of the engine acts along this direction. See this one. This arrow represents the force of the engine. So this backward arrow represents force of the friction. These two forces are opposite in direction. Next one. See this one. The entire weight of the car acts in the downward direction due to gravitational pull. So this is force of gravity. This is force of gravity. Next one. This surface exerts an equal and opposite force. Okay. This force is known as what we call it normal force. Okay. What is this? Normal force. So this is the force of gravity. Force of gravity and normal force are opposite. Both are opposite in direction. Whereas force of engine and force of friction both are opposite in direction. So this is the free body diagram of a car. You can draw any free body diagram. Okay, you can draw any free body diagram. Okay, to draw the free body diagram, you have to remember to represent all the forces that are acting on the body. Acting on the body. Are you clear about that one? So you have to mention the magnitude also. For example, here I have given 20 newtons. So here 30 newtons, like this. So you have to mention the magnitude also. Here also, force of the engine. What is the force of the engine? So you have to mention the magnitude of the magnitude. At the same time, you have to mention the direction, in which direction the force is acting. Because we studied force is a vector quantity which has both magnitude and direction. That's why you have to mention magnitude and direction of the force to draw the free body diagram. So these diagrams are known as what we call them free body diagrams. So diagrams used to show the relative magnitude and direction of all forces acting upon an object in a given situation is known as what we call it a free body diagram. I think children, you are very clear about this concept of free body diagram. Now let us do one sum related to net force. How to calculate the net force? See this one. I kept a wooden box here. I am applying 10 newtons force and 20 newtons force along this direction. Next, on the other side, see this one, 8 newtons and 7 newtons. These two forces are acting in this direction. These two forces are acting in the opposite direction. So net force acting on the wooden box is equal to 10 plus 20. Why? Because these two are acting in the same direction. Minus 7 newtons and 8 newtons because they are acting in the opposite direction. So you have to subtract the forces that are acting in the opposite direction. So 10 plus 20 is 30, 30 minus 15 is 15 newtons. What is that? 15 newtons. Are you clear about that one? Now come to the second example here. See this example. See this is a body or a wooden box or anything else. You can take anything else. So four equal forces are acting here. 5 newtons, 5 newtons, 5 newtons in all the directions, in all the four directions. Are you clear about that one? So what is the net force? What is the net force? The net force is 0. What is that? The net force is 0. So is there any motion in this body? No, you didn't find any motion in the body. But what can the force can do? Applied force can do? It can change the shape of the body. It can change the shape of the body. It do not result in any motion. Okay, are you clear, children? Now you do the textbook worked examples and textbook sums. If you have any doubt related to net force and free body diagram, you please post your doubts to my mail address. Thank you, children, for watching my class. Okay, if you like my video, please subscribe to my channel. Thank you, children.